To create a Scala project, we need to define two files. One is build.sbt and the other is plugins.sbt. Plugins.sbt tells SBT to fetch the dependencies that are required, and build.sbt tells the SBT to enable scalajs plugin. Once this is done, run the commands sbt update and then run the command sbt eclipse. This will create a Eclipse project. Once Eclipse project is created, you can start writing your application logic using Scala. As you can see, I have created a Scala object here called Scala functions that implements the functionalities required to be exposed to the JavaScript environment. So here I have defined two functions called Fibonacci and fibTail. The first one calculate the n Fibonacci number using the traditional recursive way, and the second one uses tilt recursive way. Similarly, I have implemented the application logic to perform symbolic differentiation using the feature called pattern matching using Scala. One thing you'll notice is that I've used the annotation called JS export. This tells the compiler that it should be exposed to the JS environment with the same names. Once this is done, run the command sbt full of JS. This creates a file which is a single JS file containing all our implementation. Now copy this file into your XDK project and place it in www/js folder. Once this is done, you can design your screens using XDK editor and hook up the events to its JS functions. To enable the implementation that we have implemented in Scala, all we have to do is we have to include the JS file that has been created in the HTML file. In the hooked up function, you can observe that I'm creating an object of the class which we have implemented in Scala. Once the object is instantiated, we can call the methods that are available for that particular class. Let's see the application in action. Clicking on the button called the JS functions which we have implemented in Scala, we can observe that to find the 42nd Fibonacci number, it takes around 6.6 seconds using traditional recursive method, which is way too much. Let's call the tail recursive variant. Wow, it took only 0.17 milliseconds. This was possible because Scala compiler has converted recursive call to iterative calls, which has reduced the overhead and improved the performance. This is just one instance how Scala has helped us. Similarly, you can see other features like pattern matching can help developer to write clean and precise code. On top of it, we always have compiler warning us of any errors throughout the development cycle. So here you can see the compiler, it's telling that num is not found. This can be a simple uppercase lowercase error, but compiler could find it at very initial stage itself. Now let's see how we can find the symbolic derivative of any given function. For instance, let's find out the derivative of x sin x plus sin x it is sin x plus x cos x, which is correct. All this is possible because we could use best of the both worlds, that is ease of programming when developing using Scala and the JS environment which runs on all the platform. And the applications we have created can be targeted for multiple platforms without a single line code change, still be able to implement complex logic with ease and good quality. I hope you enjoyed it. Thanks you once again.